Here we go. Very slowly, but we're gonna get her done. We're gonna go through a series of things such as evaluating common log functions, evaluating logs with other bases, and we're gonna solve basic exponentials and log equations, and we're gonna solve general exponential and log equations. And we're gonna talk about converting between exponentials and logs. The reason why we're doing this is because exponentials and logs are inverses of each other. Okay. Go. Okay. Here are our log function rules. So if you like to take a moment to write them down, or you can always go back on your bright space and write them down. But these are our log rules. Okay. So rule number 1 is our product rule. So this is called the product rule. And the product rule is saying is when you're multiplying two things within a log, that you can also separate them and add them. Okay. Rule number 2 is our division, our quotient rule. That's what they become. You know how we have exponents? When you multiply exponents of the same base, they are being added together. Same thing with logs. Okay, and then last is our power rule. The power rule is a little different. We'll go with it. It did some weird. The power rule, it's saying that the power, it actually becomes the coefficient. Okay, this all applies when D is greater than 1. And M, N, and K can be any real number. But for logs, they must be positive. And the reason why is that because our logs only function in quadrants 1 and 4 because there's an asymptote that prevents it from going any further. Okay. All right. Next. Huh? Okay. Product quotient power rules. Next, we're going to talk about converting between logs and exponentials. Okay. So when you can write a log as an exponential, what ends up happening is that the base of the log becomes the base of the exponential. So notice how my base is A, it becomes the base of the exponential. The solution of the log becomes the power. And then what was inside the log becomes your solution. So this was your base, and this becomes your power. Okay. And it's the same for common log, but common log means that you have the invisible base of 10. So with common log, you won't actually see the base. You just got to know that it is a 10. And then natural log is ln of n. Natural log means that you have log base e, which is why when you write it, its base is an e. Yes. Okay, so let's see how these come into play. Oh, sorry. It is like really raining. All right. So let's talk about simplifying. So here it says the log of 10,000 equals what? What is it going to simplify? So what would it simplify to is what it's asking us. So this is common log. So we're saying 10 to what power? So 10 to what power equals 10,000? So x equals 4.
8.
Okay. I deem it all important, but it's up to you.
This is all we do.
Okay. So you have log of 10,000 equals x, and we're simplifying it. So if we're taking the 10, because remember it's common log, if there's no log there, then it automatically is 10. Got it? All right. So on this one, it's a 7 to the 0. Well, what's anything to the 0 power?
0.
No. 1. So this is actually saying log of 1 equals x. So when we're looking at this, we're saying 10 to the what power equals 1. So what power would x have to be? 0. Yeah.
How do we know that each original log is common?
If there is no number, no base here, then it's automatically common. So it's automatically working with 10. So if there's nothing there, then you're automatically working with a 10.
What do you mean base?
Base?
Yeah, base where?
The base of a log, it's a small number at the end.
Oh, so like it wouldn't be like log 2?
Uh-huh. But when there's no log there, then it is automatically a 10. You're working with All right, here we have log of 1/10, 1 over 10. And so if I have log of 1/10, I'm asking, this is actually saying log of 10 to the negative 1. Does that make sense? So when I rewrite this, I already know that my base is 10. And my, let me rewrite it. That's not the real eraser. Fake eraser. So I'm going to go back a slide for you here in a second. When I have a power, what did the power rule says I can do with that? What did you write down for the power rule? So the power rule says that your power can become your what? Your coefficient. Your power becomes your coefficient. Do we see that?
Oh.
So what used to be, so our power becomes our coefficient. So when we come here, this -1 is going to become our coefficient. So this equals -1 log 10. Which equals x. So we're saying, what would this simplify down to? So that gives us 10. So our base is 10. And then our x in this case would be what? Would it be positive or negative? It would have to be a negative, right? So 10 to the what?
What do we mean, -1?
It would just be -1. Wait, yeah. So it becomes 10 to the -1. It's how that can be written as.
And that's it.
This is what I wanted to write. It's gonna be it today. All right, next we're gonna talk about square roots, radicals. Does anyone remember how to write a radical as a power? No one remembers how to write a radical as a power?
The power.
Uh-huh. Okay.
Um,
A radical as a power means that you're writing it as a fraction. Whoa.
Okay, I'll assume that. I want to be wrong.
So it becomes log 100 to the 1/3. Oh, sorry. I wrote this wrong, guys.
Not negative, so
I know. I just had to think about it. Right here, this is called our identity rule. Log 10 of 10 equals 1. Yeah. So this is our identity. So log 10 is going to always be, it's another way of writing 1. You know how we have x to the 0 that is 1? Well, if you have log 10, it's going to be 1. So you're left with -1 times 1, which equals -1. I know, I just thought about it. I was like, that does not look familiar and did not feel right in my spirit. Let's blame it on the Dayquil.
yeah, but they put that you could go sleazy.
I'm gonna blame it on the Dayquil. All right, so again, when you have the power becomes your what? Your coefficient. The power becomes your coefficient. And you're left with log of 100. What is my pen doing today? It's also on Dayquil. Yeah. I blame it on the Dayquil. Okay, so this is saying you have 1/3. 10 to what power equals 100? 2. So your final answer would be 2/3. That's what the log base of 10 is asking you. So what power of 10 will give you this value?
Yeah, there's something wrong.
My phone.
I'm sorry, it sounds like an Ember Lake.
So
Can you,
I'm trying to like.
does that,
Oh, yeah, long doesn't-
yes. So if you look right here, remember how I started off by rewriting it for you? So when it said log of 10,000, I asked you, okay, that means 10 to what power equals 10,000? And we said 4. Okay. And then here we simplified 7 to the 0 power is 1. So we're asking 10 to what power equals 1? And the answer was 0. Okay. So here we were asking 10 to the -1. So 10 to what power equals -1? Well, it's just going to be 1 because 10 to the 1 power is 10. And that's why it's called the identity. It's going to equal 1 and then we multiply. Same thing here, asking you 10 to what power gives me 100? And you would say 2, and 2 times 1/3 is 2/3. All right, log 0. 10 to what power equals 0? Is that possible? No, so then it is no solution. Does that make sense? So there's nothing you can put 10 to that's going to make it equal to 0. Got it? All right. So here we have the number of malaria deaths in millions X years after the year 2000 can be modeled by d of x equals 9/10 times the log of 10 minus 2/5 x. Evaluate d of 5. So it's asking us to substitute in substitute in x with 5. So we have 9/10 times the log of 10 minus 2/5 times 5. Okay, so we have 5. What's going to happen to the 5s? They cancel out because it's a 5 in the numerator and a 5 in the denominator. So they're just going to cancel out. So we're left with 10 minus 2, which is log 8. So now we're down to the 9/10 log of 8. So when we get here with log base 8, is that going to be something we can easily do by hand? No. If I ask myself 10 to what power equals 8? 10 to, I don't know, I don't know off the top of my head. So I'm not going to pretend that I do. I'm going to, so we did as much as we can by hand. 10 mil. You said 10 to what power equals 8?
Oh.
Okay, so when I open my handy dandy calculadora, I'm going to type in 0.9. I'm going to type in log of 8. Hit enter, and I get 0.8. Okay, now I want to show you what happens if I just put in log of 8. So 10 to the what power equals 8? Well, 10 to the 0.9 power. 0.903 would equal 8, in case you were wondering.
Is that why the 0.9 exploded?
No, that's just what the formula was. So then we're approximately at 0.81. And this means what? What does 0.81 mean for this problem? What does D equal? Huh? What does D equal?
That's what.
Deaths in millions. So we have 0.81 million
Oh, malaria
deaths.
stands for bad air in Italian.
Really?
Malaria.
No.
Bad air.
No, I did it, Gregory.
Ellen had this morning.
Okay. So malaria death was, and this would be 5 years later. So this was modeled by what year with this? Because the 5 plus 2000. So in 2005. So people are still dying, or well, we're still dying of malaria. And quite a bit.
Is that what you got?
No, I think it's just me being, cold. All right. Now, natural log. I just want to show you natural log. It is the same rules. The only difference is instead of log, it is what? ln. Okay. But you still have your product, your quotient, and your power rule. Okay.
4 letters.
The only difference is that one is natural log and one is common log, or log of any base. All right. Again, you can write ditto on your log and your rules you already wrote. It's the same rules. Just one has ln and one has log. Oh man.
The way this sounds in my head, I don't hate it.
What's wrong?
Oh,
You'll go back. All right, here we go. We're gonna write. So your first problem is we have log base 3 of 81. And we want to know, what does this equal? So what does this equal? Okay, so you're asking yourself, 3 to what power equals 81? 3 to what power equals 81? 3. 4. So our answer would be x equals 4. Doable? All right,
That's so good.
okay, so let's try it again. You're asking yourself 4 to what power? So 4 to what power equals 1/64. Okay, because it's a fraction, you know that it has to be what kind of power? Negative. Because it's a fraction, you know it has to be a negative power.
Secretary.
So we have negative. Is it -3 or -4? 4 times 4 is 16. 16 times 4 is, yes. All right, again, now we're saying again here, 4 to what power equals 16? 2. I need you to say it with some confidence. I was like, why are you hesitant on this too? Why are you hesitant? Believe in yourself. All right, now this again is called an identity. Anytime you have the natural log of E, it's always whatever the answer is. So if I have natural log of E, this is rewriting it as a very weird thing, but when we rewrite it, it becomes 0.67. And natural log times E equals 1, because this is an example of an identity. When you have the log times its base, or its inverse, sorry, it's going to equal 1. And so 0.67 times 1 is just what? 0.67. Okay, another example of this is when we had log of 10. And what did we say log of 10 equals? 1. So when you have natural log of E, it also is going to equal 1. And vice versa. If I have 10 to the log or E to the natural log, they're all going to equal 1 because they're inverses of each other. All right, questions? None? All right. So now we're going to talk about the log function. Here's your log function. I'm going to pause. I'm going to stop here. So we worked with the, we got 35, right?
Yeah.
Okay.